Hi, this is Mrs. Kidman, and in this video, we are going to be reviewing surface area and volume. So this is something that you probably have seen before, but we want to just talk about it because in a future video, we're going to talk about the surface area and volume of composite 3D solids, and so we need to make sure that we know how to do it of a single 3D solid, so then as those composites come, we know what to do. So let's start by reviewing what is surface area and volume. Well, when we think about surface area, what we're talking about is we're talking about the total area outside of a 3D shape or a 3D solid. So for example, when we're talking about the surface area, if I had something like a cube here, the surface area of this cube would be the area of all 6 sides here. Okay, plus those bottom sides, right? So it'd be the area of all 6 sides. That's the surface area. So sometimes I like to think of it as how much material do I need to build it? So what is there? How much do we need? Volume, in comparison, is how much does it hold? And so that volume tells us what is the amount of something that can fit inside. So again, with our cube, what we're talking about is if I were to use this cube here as something with that I was putting into, I want to know how much can I fit inside? How much does it hold? What is that total space inside our cube? So the way that we calculate surface area and volume is we oftentimes actually end up using the area of different polygons and other shapes, as well as the height. So let's review area really fast. So to find the area of a square, we do the base times the height. Same with a rectangle. A triangle is base times height divided by 2. A circle, remember, is going to be pi times our radius squared. A parallelogram is base times height, but remember the height is here, not always like this. It's not the side of the shape, it's on the inside, kind of like a triangle. A trapezoid is 1/2 base 1 plus base 2 times the height. A rhombus or a kite is half of the product of their diagonals. And to find the area of a regular polygon, what we're going to do is take the number of sides and multiply it times whatever the distance of sides are. So this n here refers to the number of sides. So what we'll do is we'll take the number of sides, multiply it by how long one side is, and then multiply that by this distance, and then we're going to divide it by 2. The reason why is because really what it does is it creates these triangles. And so what we're doing when we're finding the area of that is we're finding the area of each individual triangle there. It's pretty awesome. Now that does only work with regular polygons, so keep that in mind. So coming into surface area and volume, we are going to talk about surface area and volume of 5 specific things: prisms, cylinders, pyramids, cones, and spheres. So what makes something a prism is that we have a shape that is then held throughout for the remainder of it. So this is a triangular prism here in this picture, but we also will often see rectangular prisms. So that's something that might look like this, right? We'll see something like this. We can see pentagonal prisms. So one that is a pentagon that goes on in that same shape, things like that. And so as we look at these prisms, prisms just mean that they hold their shape all the way through. Now, when it's a prism, that means that it has a polygon on either end. A cylinder is not considered a prism, but a cylinder is where we have a circle that's then pulled through. A pyramid, we can have any type of base. So this one is a square pyramid, but we can also have a triangular pyramid as well. They both use that same formula. Except for let's add in that formula for the volume here, which is 1/3 the area of the base times the height. And then we also have our equations here for finding the surface area and volume of a cone, where this is the radius, this is the height, and this is actually that linear distance of our cone, and then we have our spheres. So with these in mind, what we're going to do is we are going to find the surface area and volume of different shapes. So make sure that you take note. A prism, to find a surface area, we are actually just going to add up the area of each side. The volume is the area of the base times the height. For a cylinder, the surface area is 2 times pi r squared because we have 2 circles, and pi r squared is the area of the circle, plus 2 times pi r times h, which is actually the area of this rectangular shape that goes around our cylinder, where h is our height and 2 pi r is actually the circumference of our circle. Now a pyramid, to find the surface area, we just do the sum of all the sides. So the base plus the sum of the 4 triangles that it creates, or 3 triangles, or however many. The volume is going to be the area of that base times the height divided by 3, or times 1/3. For a cone, the surface area is going to be pi r squared, which is this area. And then to figure out what this like triangular circular thing that we have that goes around to make it cone shaped, we actually do pi times r times this linear distance there. The volume is 1/3 pi r squared times the height. For our sphere, the surface area is 4 pi r squared and the volume is 4/3 pi r cubed. Okay, so let's keep that in mind to figure out the surface area and volume of some of these shapes. So this right here is a pentagonal prism. And so to find that surface area, what we're going to do is we actually just want to find the surface area of our 2 pentagons and all 5 of these sides. So to figure out the area of these 5 sides, now this is telling us that these are 6. For my 5 sides, I know that it's going to be, we have 5 of them, and they're all the same. They're going to be 12 by 6. Plus, we've got 2 of these pentagon shapes. And remember, to find the area of that pentagon, we are going to do 1/2 times 4.1 times 6 times the number of sides. Now, this will tell us how much material we need to build it. So let's go ahead and plug that into our calculator there. So 5 times 12.6 is going to be 63 plus, I'm going to do 2 times, and I'm going to multiply all of these. So 1/2 times 4.1 times 6 times 5 equals 61.5. And then we've got 2 of those. So what we end up getting is 63 plus our 123 for this, and plus that 123 gives us 186 yards squared. Now notice on surface area, our units are squared here because it is a type of area. So to build this pentagonal prism in the size that they have it, with really where those we have it 6 yards by 6 yards by 6 yards by 12 yards high, things like that, it's going to take 186 yards of whatever material we want to use. Pretty awesome. Okay, now with that in mind, let's go ahead and find our volume. So the beautiful thing about this is we actually already found the area of our pentagon, and that is this equation here. So after we found that area of our pentagon, we know to find the volume, what we're going to do is take the area of that base, which is that 61.5 yards, and multiply it times our height. So 61.5 times our height, which is 12. Our volume is going to be hello, that's fancy. It is going to be 738 yards cubed. That's quite a bit. So remember that a yard is, there's 3 feet in a yard. So that's huge when you think about it. So that's how we can find the surface area and volume of a prism. We can do the same thing here with this rectangular prism. So to find that surface area, what we want to do is find the area of all the sides. So this top here is going to be 81, and the top and bottom are the same. So we've got 2 times 81 plus we've got these 4 sides. It looks like the height's all 6, and because those top ones are square, we've got 4 sides that are all the same, that are 9 times 6, or 56. So I've got 2 81s plus 4, I said 56, I meant 54s. And then as we multiply those out, we get 2 times 81, or 162, plus 4 times 54, which is 216. And when we add those 2 things together, we end up getting 432 kilometers squared. Now, I don't know about you. I don't really know what kind of box we're building here. That is one huge box. Okay, then to find our volume, what we're going to do is we're actually going to do the area of the base times the height. So that's going to be our 81, which is the area of the base, times the height, which is 6. So our volume is going to be 81 times 6, or 486 kilometers cubed. Fantastic. Okay, so that's how we would do it with a prism. Now let's take a look at these pyramids here that we are going to find the surface area and volume of. So remember, to find the surface area of a pyramid, what we're going to do is we are just going to find the sum of the area of all the sides. And to find the volume, we are going to do 1/3 the area of the base times the height. Okay, so let's figure out what these are. So finding the sum of the areas, well, let's start with this first one here. Our surface area is going to be, well, the area of our base is a 7 by 8. So that's 56. And then we want to be able to find the area of our pyramids here, and we need this length right here. So we actually can't find the surface area of that shape there. But let's hop right into finding the volume. So with our volume here, to find that, what we would do is we would take the area of our base, which is 56, times the height, which is 9, and 56 times 9 equals 504 feet cubed. Okay, now I'm just going to add this in here. This was not included, but it should be for the sake of trying to find the surface area of this pyramid. So if we want to find the surface area of something, what we actually have to have is this linear length out here, kind of like we do with a cone. And to find that linear length, then we can use that linear length to find the area of our shapes there, where we do that base times that linear length of a height. So for the sake of this problem, we are going to say that that linear height there is 10 feet. Now, it might not actually be 10 feet, but we're going to do it for the sake of this problem. And then we're going to skip the surface area on this one. So to find that surface area, what we want to do is find the area of all the pieces. So 7 times 8 would be 56. Plus the area of this side, remember that's a triangle, so the area of the triangle is 1/2 times the base times the height. And we actually have, because of how our pyramid works out, with this being a rectangular pyramid, this side on the back here is actually the same as the side on the front. So we've got 2 of those, plus 2 1/2 base times height. And these are these ones on the side here that we're finding. Okay, so we've got both of those, and once we have that all then we can calculate this all out. So we end up with 56 plus 2 times 1/2. Well, that 2 and that 1/2 cancel, so plus 80 plus 70, and 56 plus 80 plus 70 will give us 206 feet squared. Okay, so that would be that surface area for that one, and our volume. I'm going to skip this other one because we know how to do that with a pyramid. Now let's take a look at these last 3 examples, one of a cylinder, one of a cone, and one of a sphere. So finding the surface area of a cylinder. Let's start there. To do that, our surface area equation here is 2 pi r squared plus 2 pi r times the height. So when we talk about this reference of r, that's our radius. And remember that our radius is actually half the distance across the circle. So if the whole distance across the circle is 20, in our problem, the radius is actually going to be 10 centimeters. So to find our surface area, our 7 here is our height, and our radius is 10. So we've got 2 pi times 10 squared plus 2 pi times 10 times 7. Now for the sake of this problem, I will write it in both terms of pi and as a number, just depending, and rounded to the nearest hundredths place, just depending on how you want to solve this out. But this one actually ends up being 200 pi plus 2 times 10 times 7, which is going to be 140 pi. So this equals 340 pi centimeters squared, which is kind of a weird number, but if we do 340 times pi, what we actually end up getting is 1,068.14 centimeters squared. Okay, so that kind of helps give us a reference point. If we want to find the volume of a cylinder, what we're going to do is pi r squared times the height. So this is going to again be that pi times our radius, which was 10 squared, times our height, which is 7. So this actually equals pi times 700, which 700 pi is actually going to be 2,199.11 centimeters cubed. So that would be our volume there. Now, when we're dealing with these shapes that have circles with them, so cylinders, cones, spheres, we have to include pi in our situation there. And so with that inclusion of pi, what we actually are going to end up doing is we can write it in terms of pi or change it to a decimal. I'm going to change it to a decimal for the sake of these problems because that'll give us a little bit more like logical sense of do I understand, like, would this logically be okay if I had something this size? Pi is sometimes a hard thing to reference, even though it's more precise than going out to a decimal. Okay, so let's take a look at this one here. As we have this one, similar to that last problem, to find the area and volume of a surface area and volume of a cone, what we have to do is we actually have to, similar to when we have to do with a pyramid is we actually use that linear distance here with our surface area. So to find the surface area, I'm actually going to switch colors to blue so that we can see the difference between this one and the cylinder. With our surface area here, what we're going to do to find a cone is we're actually going to do pi r squared, or the area of the base, plus this pi r times L, where L is actually going to be this length right here that runs down the side of our cone here. Now, it's actually pretty cool. We can use the Pythagorean theorem to figure this out if we have a cone that's perpendicular, where it's like the top is right in the center. We can actually use that Pythagorean theorem to calculate that, which is really awesome because this side with the height and the radius actually make a right triangle. So our surface area here is going to be pi times our radius. In this case, they did give it to us, 4 squared, plus pi times 4 times 9.8. Okay, and then we can figure this out. So this is 16 pi plus 4 times 9.8 is going to be 39.2 pi. And we can then combine those, 16 plus 39.2 plus 39.2. Sorry, my calculator is weighing out on me. 16 plus 39.2, 55.2. Woof. 55.2 pi, which really is 173.4 kilometers squared. Okay, now let's go ahead and look at the volume of this cone. Now to find the volume of a cone, what we're going to do is 1/3 pi r squared times our height. Now this cylinder and cone have a similar relationship. Notice how they're very similar. The only difference between the volume of a cylinder and the volume of a cone is that a cone is actually 1/3 the volume of a cylinder, which is pretty awesome. You can kind of explore that idea to figure out why it works. But we are going to keep it consistent and go with this. So we've got 1/3 pi times 4 squared times our height, which is actually that 9. And so then we've got 16 times 9, which is going to be 144. So we've got 1/3 pi times 144, which really half of 144 is 48. So we have 48 pi, which can also be rewritten as 150.8 kilometers cubed. Now this cone is a huge cone. If you think of it as a kilometer, remember a kilometer is like 0.6 miles. Humongous, but that really does work out there. Okay, let's take a look at one last example, our sphere. So I'm going to switch to the color purple. Purple is kind of fun, which is why I want to use it. Okay, so we've got our surface area. To calculate the surface area of a cone, or of a sphere, what we're going to do is it's 4 pi times our radius squared. So our radius here is 1, and so we're going to do 4 pi times 1 squared, which in this case is 4 pi, and 4 pi is 12.56. So we have 12.56 kilometers squared. Awesome. And then to find our volume here, what we're going to do is our volume is actually 4/3 pi r cubed. So we're going to have 4/3 pi times our radius cubed, which actually makes this 4/3 pi. And so we've got 4/3 pi, which is 4.19 kilometers cubed. Okay, so it's really interesting about our volume and our surface area because typically for everything else, our surface area is less than our volume, but when it comes to a cone and it comes to a sphere, they actually are more than our volume sometimes, which is interesting, but pretty cool. So again, using these different formulas here to find that surface area and volume, we can find the surface area and volume of any shape in one of these forms. So any type of prism, any type of pyramid, a cylinder, a cone, a sphere, regardless of what they look like. And then we can then apply those to figure out those volumes and surface areas of different things. If you have any questions, feel free to reach out. But that is how you can find the surface area and volume of 3D shapes.